And the example I've chosen for that is the example of oracles. So I want to show how to implement a very simple oracle. Now, what is an oracle? An oracle in the blockchain world is a service or a way to get real-world information onto the blockchain and make it usable in smart contracts. And there are numerous examples or use cases for that. So you can think of external data sources like weather data or election results or stock exchange rates, or maybe randomness for games or lotteries, or simply time, temperatures, water levels, all sorts of things. And often information like that is useful or needed for a real world smart contract. For example, you could have a betting smart contract that depends on the outcome of a specific sports game. And in order for the contract logic to decide who wins the bet, you of course need the information from the real world who actually won that game. Or maybe you want some trading contract that takes real world stock exchange data into account. And there are various ways to implement oracles of various sophistication. And I want to choose a very simple approach where we have one trusted data provider that provides one feed of data. And as an example for data, I want to use the exchange rate from ADA to US dollar. And of course, there are lots of problems with this approach because you have to trust that source, this data source. And there are also ways to mitigate that risk, the risk that this data source is either untrustworthy or unreliable. Maybe reports wrong data, or for various reasons, technical issues or whatever, fails to provide any data. So for example, you could make the trusted party to put down some collateral, high collateral, and then have some sort of mechanism that if the provider fails to deliver or reports false data or doesn't report data, he loses this collateral. Or you could combine several such oracles into one, like only accept the value if all these various sources agree, or only take like the median or the average value of these different sources. Or you can think of much more sophisticated mechanisms. But for this example, I think it's enough to take the simplemost case where we have one data provider that we trust and that is willing to provide this real-time data to the blockchain. And as we know, for anything to happen on the blockchain, there must be a UTXO. So the obvious idea is to represent this data feed, the current value of the data feed, the Oracle data, as a UTXO. That UTXO sits at the script address of the Oracle, and in its data field, it carries the value, the current value of the provided Oracle data. So in this example, the datum would carry the value 1.75. And this is where we encounter our first problem. Because as I have said many times in this lecture, validation only happens when you want to consume something from a script address, not when you produce an output at a script address, which means that we can't prevent anybody from producing arbitrary outputs at the same Oracle script address. So we somehow need a way to distinguish the true UTXO Oracle output from other outputs sitting at the same script address. Luckily, we learned about NFTs in the last lecture. And the point about NFTs, if you recall, is that an NFT can only exist exactly once. So there's only ever one coin of a given NFT. So the idea to make the correct Oracle script output unique is to give it an NFT in its value. So not only have it carry the data, the actual Oracle value, but also put an NFT at that output. And because an NFT can only exist once, there can only be one output at the Oracle address that holds that NFT. And that allows us to uniquely identify the correct UTXO that carries the correct Oracle value. How can such an Oracle be used? And here we come to something we haven't seen before. In all our previous examples, when we designed validators and contracts, we always knew the full API upfront. So we always knew exactly how we intend to use our smart contracts. In the case of an oracle, this is different because at the moment when the oracle gets created, you don't know how people might want to use the data feed provided by the oracle. So in that sense, it's like an open API. The oracle must be able to work together with smart contracts that haven't even been written at the time when the oracle is created. So as an example for use case that might make use of this specific oracle, let's consider a swap contract where at the swap address somebody can deposit ADA and then somebody else can take those ADA in exchange for US dollar. Of course, we don't have US dollar directly on the blockchain, but let's just assume they are represented by some native token, some USD native token. So we have this swap contract, and somebody can make a swap by exchanging the ADA in the contract for the USD token. And the idea is to make use of the oracle by determining the exchange rate by the oracle value. So in this example, because the current value of the oracle is 1.75, if somebody offers 100 ADA in the swap, the price for that should be 175 US dollar. In addition to that, we also need an incentive for the oracle to actually provide the data. Because if nothing else, the oracle provider has to pay transaction fees to actually create this UTXO. So let's say that the oracle provider determines a fee that has to be paid each time the oracle is used. So for example, let's say the fee is 1 ADA. So each time the oracle value is used in a transaction, the user has to provide 1 ADA fee. So this means if in this swap example, the buyer wants to buy the 100 ADA, he would need to pay 175 US dollar to the seller of the ADA and 1 ADA to the oracle provider. So what will the swap transaction look like? First of all, the swap validation logic will need access to the current oracle value, which means that the oracle UTXO must be an input to the transaction. So the swap validator has access to it. Then we have the oracle validation logic. And in this case, we want to use the oracle. So let's say we have a redeemer called use. And now the oracle validator has to check several things. First of all, it has to check that the NFT is present in the consumed input to make sure that the correct UTXO is used. Secondly, it has to make sure that there's also an output of the transaction at the same oracle address, again containing the NFT, and with the same value. By using the oracle value, we don't want to change the value. We just want to use it. So the oracle validator must make sure that when this oracle UTXO is consumed to use it in an arbitrary transaction, like the swap transaction, the value is not changed, the datum is not changed. Finally, the oracle provider wants to get paid, so it must make sure that in addition to the NFT that identifies the UTXO, the fee must also be paid. So we have this picture that the transaction that makes use of the oracle consumes the current UTXO, the current oracle UTXO, makes sure the NFT is there, and produces an output again to the oracle address and makes sure the NFT is again there, the fees are there, and the datum has not changed. And now we can complete the transaction. So both the swap output and the price paid by the buyer are consumed as additional inputs to the swap transaction. And we have two more outputs, the US dollar that go to the seller and the ADA that go to the buyer. And that all of this is correct and has the correct values is the responsibility of the swap validator. So the swap validator will make sure that the buyer pays the correct price to the seller. whereas the Oracle validator is only interested in making sure that everything concerning the Oracle is correct, so that we have this one Oracle output consumed, which is identified by the NFT, and we have a continuing output to the Oracle address again with the correct value and the correct datum. So this is a complete example of how an existing Oracle would be used. And just to emphasize once again, this swap contract is just an example. The Oracle should be capable of working with many different smart contracts that want to make use of the data provided by the Oracle. Now, if that was all, then we wouldn't need an Oracle, because if this one value was fixed and it was always 1.75, then we could simply hard code this into our contracts. So obviously, the value of the Oracle must be able to change, at least in the case of an Oracle like this one, where we have an exchange rate that of course can change over time. There might be other Oracles like the before mentioned outcome of a sports match, where it's a singular event in history and either the one side wins or the other wins, but that will never change again. But in an example of a price oracle like this one, of course, it's important that the value can change, which means that the Oracle validator, in addition to the use redeemer, must be able to support another operation where the operator, the provider of the Oracle, can actually change the data. So let's say that the value changes from 1.75 to 1.77. And the Oracle provider needs to update the Oracle. Of course, we know that on a UTXO blockchain or eUTXO blockchain, nothing ever changes. So UTXOs can't change. You can't change the datum of an existing UTXO. All you can do is consume UTXOs and produce new ones. So in order to update the value, we have to consume the existing Oracle UTXO and produce a new one that carries the correct datum. So we would have a transaction that uses an update redeemer, and now the validation logic is somewhat different. It's the same as before in that the NFT needs to be present in the consumed Oracle input and also needs to be present in the produced new Oracle output. In addition to that, that transaction must be signed by the Oracle provider, so not anybody can change the value, only the provider of the Oracle. And we can use this update transaction as an opportunity to allow the Oracle provider to collect the fees. So we only insist that the NFT must be present in the output, but we don't say anything about other values. So all the accumulated fees that got there from other contracts using the Oracle can be collected by the Oracle provider in this transaction. So to sum up, we represent the Oracle as a UTXO, and we identify the correct UTXO by a specific NFT. And the Oracle value is the datum of that UTXO. And we support two operations. One is use, which uses the Oracle in some arbitrary transaction. And the validator in the use case will make sure that the consumed Oracle input carries the NFT and that there is an Oracle output that again carries the NFT, doesn't change the datum, and carries additional fees. The second operation is update, which can only be done by the Oracle provider. And for an update transaction, again, the Oracle input must carry the NFT. There must be an Oracle output also carrying the NFT. And otherwise there are no restrictions. So the datum can change and the accumulated fees can be taken out.